This is the third video in the series of sequences, and if you haven't watched the first two, I recommend watching them first before this, as I go through the intro and linear sequence. In this video we will go through a few examples of quadratic sequence. Just a few basics first. Quadratic sequence, we know that it's a quadratic sequence when the second difference is constant, when the second difference is the same. Second difference means when you subtract each term with each other, the consecutive terms with each other, and then subtract their differences with each other, you should get a constant term. You'll know about them when we do few examples. Quadratic sequences are generally in the form d by 2n square plus an plus c, where n is your nth term, whichever the term is, first, second, third, fourth. D is your difference between consecutive terms, the constant value, and c and a are variables that you need to figure out to solve to find the nth term formula. Now, a quick disclaimer: I am not using the standard book method for finding sequences, which most schools do. I'm using a slightly different method, a method which involves quadratic equation. The reason I use this method and not the other one is because this, although it's slightly lengthier and you need a little bit of more algebra, but it is very simple to keep in mind, so, and therefore very simple to apply in your examination. In your examination you don't have time, and students generally freak out because of the exam situation, they get nervous. So by keeping your methods and your understanding of topics simple and straightforward, you're much more it is much more easier for you to answer the question. So this is a slightly lengthier method, involves a little bit of more algebra, but it is a very simple method, so therefore you guys should find it easy, and hopefully you are able to solve using it. So let's take a simple examples of our quadratic sequence, right? So 2, 9, 18, 29 and 42. These are just simple examples. They are not meant to challenge you, they are just meant so that you guys understand the method, right? So if this was a linear sequence, the first difference would be the same. So let's do that. 9 subtracted by 2 is for 9 minus 2, if I use my calculator, 9 minus 2 is 7. 18 minus 9 is 9. 29 minus 18 is 11, and 42 minus 29 is 13. If this was a linear sequence, the first difference would have been the same. The fact that this is not a linear sequence, the first difference is not the same. Quadratic sequence have the second term to be the same, second term to be the constant, which in this case, if I subtract 9 by 7, I should get 2, 11 by 9 I should get 2, and 13 by 11 I should get 2 again. In this case, therefore 2 is our constant difference, 2 is our value for d. So if I write down the expression, this would be 2 by 2 n square plus an plus c. This is our expression for the nth term form for the quadratic sequence. From this point, it will involve algebra, but it is very straightforward. All you have to do is just set up two simultaneous equation situation, right? So we know that if I simplify this, I will get n square plus an plus c. 2 divided by 2 is 1, right, is equal to the nth term formula, right? So we know that the first term of the sequence is 2. If I set up an equation for the first term, it should be 1, because the value for n is 1. 1, 2, 3, 4, 5. 1 square plus a multiplied by 1 plus c is equal to 2. Why? Because 2 is our first term. Now you need to set up two equations. Either you can do it with first term and second term, third term, third and fourth, third and second. Doesn't really matter. That doesn't really matter. As long as there are two equations, you have two variables, you will get the exact same answer. Second equation we can set up using our, the fifth term, let's say. So 5, because n is 5, n square plus a n plus c is equal to 42 because it's a fifth sequence. We have two equations, we have a simultaneous equation situation. From this point you just have to solve just like you solve simultaneous equation and you will get your answer. Again, a simple method. All you do is find the second difference, set up two equations and solve. This is much more straightforward and much more easier to keep in mind, although it involves a little bit of more algebra, but it is very simple to keep in mind. So in your examination it's much easier to apply, and highly likely that you will get full marks. Why? Because it's very easy to keep in mind. Again, find a second difference, set up two equations and solve. So let's solve it. In this case, when you have simultaneous equation, just a quick recap, when you have simultaneous equation, we will take our first equation and we will make one of the variable the subject. In this case, let's just make c the subject. If I make c the subject, I should get 2 minus 1 minus a, which is c is equal to 2 minus 1 is 1, 1 minus a. So I'm just using this equation and making c the subject. Hopefully you guys know how to make a variable the subject. Then in the simultaneous equations, we take that value, we take that subject that we have just created and we insert it into our second equation. So 5 square plus a multiplied by 5. Now instead of writing c, we would write the expression for c which we have found from the first equation. First we have found the first sequence from the first equation. So this would be, instead of c, it would be 1 minus a is equal to 42. You have a single equation, you have a single variable, little bit of algebra, and you can find the answer. 5 square is 25, 5 into a is 5a, plus 1 minus a is equal to 42, 42. So 25 if I shift 25 plus 1 is 26, 5a minus a is 4a, so 26 plus 4a is equal to 42. 4a is equal to 42 minus 26. A is equal to 42 minus 26 is 16 divided by 4, which is 4. And once you get the value for a, which is 4, insert it back into your equation, back into your first equation, and find the value for c. If a is 4, then c must be 1 minus 4, therefore c must be minus 3. So our nth term formula for this quadratic sequence is n square plus a, which is 4, an plus c, the value for c is minus 3, plus minus 3 is minus 3 is equal to your nth term formula. Now that is your answer right there. Again, this method is slightly lengthier because you have to make simultaneous equation and you have to solve. So just being frank, if you're not good at algebra, then you need to really get good at algebra, because it's IGCSE and you will need to use simultaneous equation in multiple scenarios, in geometry, in trigonometry, and in your sequences. So it's something that's very important. But nonetheless, this method is again very straightforward, very simple, easy to follow. Let's do one more example of a quadratic sequence to really take it home. So other example of quadratic sequence could be 5, 18, 35. Again, these are not hard sequences, these are straightforward sequences. They are not meant to challenge you, they are just meant so that you understand the type of questions you will the method to solve them. Again, a quadratic sequence over here, first term, second term, third term, fourth term, fifth term. Quadratic sequence always in the form d by 2 n square plus a n plus c. Right, in this case, let's find the second difference. So 18 subtracted by 5, 18 minus 5 is 13, 35 minus 18 is 17, 56 minus 35 is 21, and 81 minus 56 is 25. If this was a linear sequence, this would be a constant value. The first difference would be a constant value. The fact that it's not shows that it's not a linear sequence. Nonetheless, 17 minus 4, 17 minus 13, 17 minus 13 is 4. 21 minus 17 is also 4. 25 minus 21 is also 4. The second difference is a constant value, which means that this is a quadratic sequence. So therefore, our equation would be 4 by 2n square plus an plus c is equal to your nth term. Simplify this would give us 2n square plus an plus c is equal to your nth term formula. Again, we will just set up two equations, simultaneous equation situation, and we will solve for them. We don't need to use the first and second term. You can use any terms to set up your equation. As long as you have two equations, you're golden. So I'll just use the first and the third term. You can use any term, doesn't really matter. So the first equation would be 2 square plus n is 1 in the first term, so plus c is equal to 5. That's my first equation. My second equation, I'm using the third term, so my n would be 3 by 3 multiplied by 3 plus c is equal to 35 because the third term is 25. Simultaneous equation situation, how do you solve them? Well, you take your first equation and you make one of the variables the subject. Let me just make c the subject because c is the easiest to make subject in this scenario. C would be 5 minus a minus 2 square. 2 square is 4. C would be 5 minus 4 is 1. 1 minus a. Again, I hope you guys know how to make a variable the subject, basic algebra. And then we take our subject and we insert it into your second equation. That would give me 3 square plus 3a. Instead of writing c, I will write 1 minus a. We are replacing the value for c with 1 minus a from the first equation, is equal to 35. You have one equation and you have one variable. Should be easy to solve. So let's do that. So 3 square is 9. 2 into 9 plus 3a plus 1 minus a is equal to 35. 2 into 9 is 18. 18 plus 1 is 19. So 19 minus 2a is equal to 35. Little bit of more algebra. Minus 2a is equal to 35 minus 19. 35 minus 19 gives us, put that in my calculator, gives us 16. A is equal to 16 divided by minus 2, which is equals to minus 8. We take that value for a and we insert it into your first equation and find the value for c. If a is minus 8, then c must be 1 minus minus 8. 1 minus minus is positive, so 1 minus minus 8 would be plus 9. Therefore, our equation would be 2n square minus, because our value for b is a is minus 8n minus, is it minus? Let me just, value for c is 9, sorry, plus 9 gives us the nth term formula. Again, this method does require a little bit of more algebra. However, this is a very straightforward method, easy to keep in mind and therefore easy to apply in your exam. Hopefully you guys understand the method, and hopefully you guys are able to apply. Yep, so thank you.